Okay, Mr. Joseph, can you hear me now?
Yes, I can.
All right, so we commence now. So today we are looking at SPSS, which is popularly known as Statistical Package for Social Science. Initially, it was known as Statistical Package for Social Science, SPSS, or later it was changed to Statistical Product and Services Solution, the acronym. However, it's being built up by IBM. Okay, so it is widely used in various sectors and functions such as health sector or health field. It's used in businesses, government, in politics, in education, in every kind of analysis that has a analysis required. So the widely, in fact, is one of the primary, apart from Excel, is one of the primary um, application used for analysis, for data analysis. It gives very strong insight into data, and then with a very complex mathematical formulas that helps in statistical terms, in statistical field, to make sure a desirable insight is fished out, right? It uses a command syntax programming, having an integration ability into Python, Power BI, SQL, etc. So it can integrate, it can get data from anywhere into it, especially Excel and CSV files into it. And then you can also send information out of it and all that. So, however, SPSS has two GUI. GUI means graphic user interface. Graphic user interface. Before that, let me launch it. This is SPSS. This is the icon. If you can see it on my screen. This is the icon. So if you double click it, you'll find the icon at the middle of your screen, and then trying to load up. Okay. So SPSS has two GUI, graphic user interface, and the first one is the data view, which shows like also we call a spreadsheet, and then the second one is a variable view, which we'll see very soon, right? The data view is where the initials of every data set is organized. Let me use that word. All the required data sets are being organized. So this is SPSS, as we say. This is the full environment of SPSS. Let me zoom it wide. Okay, so here we have our normal title bar showing that this is untitled data set 0, and then IBM SPSS statistical data editor, right? I hope you can see my screen, or should I increase it more than that? Can you see my screen? Mr. Joseph, can you see my screen?
Yes, sir. Yes, sir.
Okay. Let me see if I can just increase it a bit. Okay, so we have our normal menu bars, or sometimes called tabs. We have the file, and the edit is here, the view menu, the data menu, transform, analyze, graph, utilities, extension, windows, and then help. Okay, so we have the next bar is always the property bar, or sometimes called the standard toolbar. So these are the next one are the sheet itself. This is the spreadsheet we're talking about. Now we have both the rows and the columns, although these have been named already. This is the data view, sorry, the variable view, then the data view. Okay, so these are the two views that SPSS have, the data view here and the variable view. Now the data view here is the spreadsheet we're talking about, right? Why the variable view is where you do your setup of every information that will be used in the analysis, right? You set everything up here and then you preview them on that data view. It's just like Access. Access, you do a lot of setups before using it at the latter end of your analysis. Okay, so after that, here is just the status bar, which is the last. We have both the horizontal and vertical as well for our use. Okay, so this is just the few information about the environment of SPSS. Okay. Now, first of all, before continuing on SPSS, you may first have your data set. Now, data set can be imported and data set can be created. Now, you can set up your data set from scratch here on SPSS, or you import your data set from anywhere into SPSS for analysis. Let's look at a setup of data set. Then we'll now also look at the importing of data set. First, what kind of data set do we want to launch into SPSS since we want to create now? First, let me see how to explain each and every, although they are English names, so we could understand them, but let me still give you some information about them. Now, this first name stands for each column header. I hope you understand column header now. Yes, the first name, the name here is where you will list all your columns header. You list all your column header, right? Someone has joined us. Is that Fatima?
Yes.
Okay, you're welcome. So the name here is where you list your column header. Let me see if I can list some of them so that we understand it very well. Remember, in our previous data set, all of our column header, product ID, name, this, that were listed on each column, right? But here on this view, you list them on the rows. So, but when you come to data view, they will now take the columns here. As you can see on data view, everything is written var, meaning variable, right? So it will not take their normal position. But here on the variable view, this is where you list down all the information. Let's start, let me just list a few. Let's say student ID. And when you are listing, there should be no space. When you are typing, there should be no space. Now, I wanted to put space, but I use underscore to represent space. That is what I want you to understand. There should be no space like STD for student, and then I now space it like this without anything. It doesn't look at it now. Variable name contains an illegal character. There is a pop-up. Yes, that is shouting that variable name contains an illegal character. So there should be no space when listing your variable name. It should be a singular information. So let me say student underscore ID, right? I will come back for this, but let me list all the columns first. Then we'll come back to all this information one after the other. Then we'll set them up. Okay, so, or perhaps should I even go through? Let me list a few, and then we'll come back to it. Student ID. And we can now say name, name of student. The next one is age of student. Next one is gender. And next one is what else should we put there? Okay, let's stop there for now. Now, if you look at the type, the next thing we have here is type. The next thing we have here is type, right? Type here is asking you what type of information will be entering that column. What kind of information are you looking at? We have numeric information, we have string information, and we have some set values, right? What kind of information are you looking at? As you can see, we have numeric information, comma, we have string, we have date, we have a scientific notation, we have restricted number, etc. So what kind of information are you looking at when it comes to student ID? Is it string? And then now this width is how large is it, right? So let's assume I want to go with numeric, like numeric for student ID. And then the width of student ID. And let's also assume I want to go with natural numbers like 1, 2, 3, 4, 5, 6, 7, etc. So the width for those natural numbers should be just 2. All right. It's just I want to stop at let me say 99. So the width should be just 2. Right. And then the decimal places, I don't think I'll need any decimal place. So I don't really need decimal place. I'll just put 0 there and click OK. All right. So that is the meaning of when it comes to type. The type of information that will be entering this student ID. Let's look at type for name. Now, name is not numeric, but string. String means text. Anytime you see string in a programming language, it means it's referring to text, general alphabet. This is string. So numeric, now is referring to general numbers. So now that is text here, what kind of name am I putting here? Is it just first name? And then how large should the name be? How many characters will the name carry? So we can now say, okay, someone name let's go with just first name for now. And maybe first name, highest character in the first name, let's say 15. Just keep it at 15. Any name that is above 15 for now should just be removed. Okay, so we just click on OK. Now age is also numeric. Age is numeric, and the size of age highest should be 99. So we can keep age at 2. I don't think there's any decimal place for age. Then gender. There is something we call set values for gender, right? Of which I want us to, let me not change it for now. I'll keep it, then we'll come back and change it. when we get to values, but it will still be at numeric because we want to change male and female into numbers so that we can use that for our own analysis when the time comes. However, our width that we set as taking place, right, and then the decimal place has taken place. Here we still don't need decimal place. We can still keep it at 0. Okay. So label here can still be the same name that was here. Label can carry the same name, it's just the same thing. But assuming you wrote this in short form or shorthand, you can write label in full, right? The name in full. So now I can now write student ID. Now label, you can type it anyhow you want to type. There will be no issue. The name of student, right? And then here is age. And then here is still gender, right? Okay, so values. Values, here we need to set values. If you don't have any value, okay, let me show you what values mean. Let me set gender so that you understand. Now, under values gives, there's an understanding in SPSS that you don't really want to make use of the text of that very variable, but you want to use it in doing some serious calculations. Have in mind, statistics here there are some information that requires numbers, not text, so that they could run through the statistical processes very clean. But some of the information you got, like gender, are written in text. So once you come across such kind of information that you really need gender to do your frequencies calculation or ANOVAs or whatsoever calculation that does not need text but numbers, then you need to convert some of your text or convert the text to numbers. So once you convert text to numbers, you can now use that same figure to run your analysis, and then to revert back to the actual text that is carrying. I don't know if you understand my explanation, but however you understand it. Now, the value here for male should be 1, and then the label that it should be 1 should be male, right? And then the value 2 should be for female. Add. I don't know if you understand this now. Under gender, we only have male and female, but there are some calculations that the male under gender will not work when it is kept in text form, but it will work when it is kept in numeric form, right? So you need to convert your gender into numeric numbers, so that you can use that to run some analysis and get the insight you're looking for in regards to gender. Now, after doing this, you can now click on OK. Now, with this, you find out that the type of information will still remain as numeric. And then we can still reduce this to 2, as the case may be. Okay. But others, there's no change of information. There's no change of information at any kind or in any form. So we just keep them at none. It's only gender that we needed to change the information required, right? So missing, I don't think there will be anything missing, but if anything is missing, it is kept at none, right? That means no missing values. If there's any value missing, it will not work, right? But if you want any value to be missing, then you can activate it. All right. So missing values, none for now. No missing value, meaning that everything will be imputed. Then we have columns, and then we have alignment. Yes, this is one of the things I want us to understand. Measure. Okay. There are three measures here. First is scale, second is ordinal, and the third one is nominal. Now, scale here is for numeric values. Numeric values like student ID, any numeric value. Age is scale, any numeric value. Any numeric value. Amount of money, percentage of whatsoever, any numeric value that is purely numeric is scale. Now, ordinal is for text. Anything that will carry text, like name of student is text, so you keep it at ordinal. Name of student is text, you keep it at ordinal. Now, nominal is something that carries the race, the country, religion, and all that. So it's in between. It's in between. Nominal, something that has a boundary, right? Anything that has boundary like religion, race, country, etc. So we keep that at nominal. So we can keep a gender to be nominal, and that is it. So the role here, how will this data be inserted into the sheet or the data set, is to impute it. So we just keep them at input. And then we have some that will be dependent or independent. So we have targets to be dependent value, and then input to be independent value. Then you now have both, have partition and split. So for now, let's not just decide for now. Let's everything just to be independent. This can easily be changed when required. Okay. Mr. Joseph, Ms. Fatima, do you understand? Is there any challenge from what I've said, or should I just go back again one by one and then refresh what I was saying?
Please do that. Thank you.
Okay. Mr. Joseph?
Yeah, sir.
Should I go back again?
Yes, sir.
Okay. Now, I started by telling you that there are two information view that we have. First is the data view, that is the normal spreadsheet. And the second is the variable view, which is like a kitchen that cooks the data, right? You first of all cook up your data before taking it over for analysis. Now, why do you even need to do this cooking? Is because you are the one bringing in the data by typing them. Whereas if you import data, the SPSS will automatically go through your data and arrange all these subheadings that we just did automatically for you, except you have specific adjustments to make to each of these variables before you can now make those adjustments. But it can automatically do this for you and then get your data ready. Now, we started by saying that the name here is actual name of the row, the column, as you can see now, if I come to data view, you can now find out that all the names that were in the first column under the name are being represented here, right? Accordingly. Now, so we have the name that carries the actual name of the column. And I told you that the name of the column will not have any space in between, right? Anyhow, everything must just be a full name from beginning to end, no space, and it should not carry some should I say some symbols that may throw an error, right? So you just get those information done. No space. If you need a space, you use underscore to represent those, and then to get that done. So each of these names will depict the rest of the adjustment in regards to that very name. Now, this is student ID, and then we needed to make use of the type of information that will be entering under the student ID, just numeric 01, 02, 03, 04, 05, etc. And we highest the student we want to work with is just 2 digits information, 2 digits number, which is 99. That is the highest. We don't want to go more than 99. But as we want to go more than 99, then we need to increase it to 3, right? So that is where we have this width. The width of the information should be just 2. And then the decimal places, will you be having decimal under serial number? No. So we can now say we don't need decimal. And then the full meaning of STD-ID can be written in full under label, which is the student ID. Then values. I told you about values. Is there any value that ought to be altered? All right. Is there any value that ought to be altered? But I don't think we have any value to alter under student ID. So we keep it at none. Would there be any missing information under the student ID? We say no, nothing will be missing. All right. Column, just keep it at 8, width 8. And then alignment for numbers is always right. You just keep alignment normally. Now measure, this is where the understanding is required. Measure, I told you measure has 3 type of measures in SPSS. The first one is scale, second one is ordinal, and the third one is nominal. So scale works only on, or works for numbers alone. Anything numbers, amount to prices, so avarice is pure number. Anything number, and the number keep on increasing or decreasing. So you use scale for the measure, right? So anything text, write up, strings, you use ordinal to represent such. Now, nominal is in between. So we use nominal to represent any information that will come in between numbers and text. Any mixture of such, you just keep it at nominal, right? So the input for now, we just keep them at the role, we keep them at input. But there are some information you may need to specify that this one is my target. This one is my input. Now, input means an independent variable. Input itself. That means all these guys are independent variable. While target means a dependent variable. And then you can choose to keep anything that is in between both of them on both, and you can still keep it at none and all that. So, but for now, let's leave input for the meantime. All of them should just be input. And then we will continue from there. Now, let's see what we could do as we go forward. Let's check an information called hemoglobin levels. Let's use that to just glance through SPSS and see what it could give us. Hemoglobin levels. So let me write HEA. You know anything about hemoglobin? Do anybody know anything about hemoglobin?
No,
Yes,
it's
sir.
not a blood it's,
Oh, okay. Okay. Oh, I want to shorten it. I'm looking for how to shorten it. It should be HG levels. Okay. So HG levels will be numeric, right? So let's keep the width at. Let's keep the width at. Have in mind you can do the editing directly. Let's keep it at 2. Let's keep the decimal point at 1, and then hemoglobin. Hemoglobin levels, and the values is none. Missing is none. Columns, let it just be at 8. And the measure, let's keep it at scale. All right. So let's go into our data view. Okay. So let's start with student ID. Let's say 1. And the name, let's say Nani. And then age, let's say Nani is 13. Let's say is a female. Okay. Female is 2, right?
yes.
You see what? Beautiful. Are we saying he bounced back my 2? I mean my female. So hemoglobin levels, let's say 10.2. Okay. So number 2 person, Cassie. Let me just start with capital C. Cassie, age is 14. He's a male. And then his hemoglobin is 9.7. And then number 3, let's look for another person. Dadine. Dadine is 13 years. And he's a guy, 11.3. Number 4, let me just get these numbers down. Named Victor Gabriel, Sally Sue, Faith, Antonia, Debbie, Samuel, Rita, George, Savvy, And then Sarah. Danny. You have Danny before? Let's just have up to 20. Then Tina, Vicky, and then what is this? Rina and Sam. Or who? Blessing, right? So we have 20 persons here. Um, 5, 6, 7, 8, 9. Okay. So let's give them random age. This is 10. This is 13, 12, 11, 10, 14, 12, and 10, 12, 11, 14, 13, 13, 11, 10, 12. Okay. And then gender, Victor is 1, Gabriel is 1, is a male, Salisu, male, Faith 2, Antonia 2, David 2, Samuel 1, Rita 2, Josh 1, Josh 2, 1, Savi 2, Sarah 2, Danny 2, Tina 2, Vicky 2, Rina 1, Blessing 2. All right, so here we can give them different hemoglobin level. So 12.1, 13.2, 14, 11, 11.3, 11.4. At this point, Fatima, help me check the normal hemoglobin for children, normal hemoglobin level for children. 12.1, 13.3, 14.1, 13.2, 12.1, 11.0, 9.8, 9.8, 9.9, 10.5.
10.5 to 24.
All right. Okay, let's write that down. 10.5. Okay. 10.6. Check the adverse effect of hemoglobin that is below low hemoglobin and the adverse effect of it. And then check, Joseph, help me check the highest effect of high hemoglobin level for children in children, high and the effects as well. So we also have information that we're working with. Okay. So at this point, having gotten our data set up and then the data is ready, we can start with some of the little minor analysis as regards our data. Now, one of these menu that you will use very rampantly is this menu. Analyze menu. This analyze menu will be your serious friend. Then your graph will come into play. However, file is a normal file understanding. You have you open, close, new, etc. So there's nothing much that is different. Edit is our normal editing. As you can see, we have our undo, redo, copy, paste, and then insert cases as the case may be. It's not really new. We have our view. There are things you want to view. View levels, you can activate them. Activate it, and it's also here. So, and what else? There are toolbars if you want to view them. Just come and deactivate or activate them. We have our data menu. There are some information that you may need to come here to read, go through it. You know about transpose, you know about sort cases, and then adjustment, restructure as the case may be. Some of them we need to talk about them as we go on this in previous subsequent classes. And then transform menu. We have rank cases, date and time wizard. Remember when we created a new date table in Power Pivot, Power Query wizard. So you can use this as well to create date and time information as the case may be. So we even have replacement of missing values as the case may be. So, but this analysis is where all the or what SPSS can really give when it comes to analysis is under analyze, right? Every step, every analysis in SPSS is under here. As you can see, we have a lot of them here. Power analysis is there. Report, all of them has extra information embedded in them. We report descriptive, Bayesian tables, compare means, general, mixed models, correlate, regression, log linear, neural network, right? Multilinear. This is a highly, a very powerful tool. Neural network is a powerful tool that helps in extracting information from a categorical or classification data set, right? We have something you could use. We have classify here, dimension reduction, scale, even forecasting. You can now use this to forecast whether something will happen in future or not. Then survival, will this thing survive? The half-life of it, etc. A lot of you'll be making use of all this at your spare time. You need to even simulations are here, complex samples. In fact, by God's grace, we'll just see how to touch few of them. Then we'll get use of them. And then the next one is the graph. After analyzing, we may need to bring out some information for visuals so someone can really get the understanding of your data even at a glance. So we have utilities here, and we have extension, help window, and the normal help. Okay, Joseph, have you seen the adverse effect of high hemoglobin and the level for high hemoglobin?
Should I say what I?
Yes,
What?
please.
Okay, so for low hemoglobin level, the adverse effect is that it reduces oxygen delivery to body's tissue and organs, and this leads to anemia and systemic fatigue.
Okay, for low hemoglobin. And when they say low, what value is the low?
I didn't go further to check that. Let me see.
You say normal is 10 to 24.
Yeah, the
So
normal is
low should be below 10, right?
below 9, I think.
Okay, below 9.
Yeah, below 9.
Then high should be above 24.
Okay, so what I have here is anything below 7 point. Anything
Okay,
below 7, yeah.
okay, 7.
Yeah, it's
So
considered life threatening.
high should be high should be high should be from 25. And check the adverse effect of high, which is
High
actually
is
high.
from 16.5 to 17.5.
Okay, that means this 24 is not normal. So 10 to 15 should be normal. Then high is 16 to 17. What is the adverse effect?
Blood clot, stroke, heart attack, high blood pressure.
All right. Okay, so I don't know if we should get somebody close to the high, or someone should even have the high, and someone should have the low, right? So that we could have some information in our disposal. Or let me say, let's give Sally Sue 7.1, and then let's give George here. George should have 16.5, right? And then Nani 7.0, Vicky 17.2. Okay, so we have some few high and low information. Okay. Now let's look at some of the analysis we need to work with. We'll just start from the preliminaries, and then we'll graduate step by step as we go. Now, very simple. Come to analyze, and then let's come to descriptive. Let's start with descriptive. Let's pick frequencies first. Now, someone will say, why didn't you start here? This is mean, right? We'll come to it. This report, we don't want to do report for now. Let's pick up descriptive for now. Now, descriptives or frequencies, they naturally work with numeric numbers, right? Most of the times. Now remember that our gender also have numeric number, which is 1 and 2. You see, so though it is written here as female, if I off this value, let me close this so that you know that it's still 1 and 2. Look at it here. If you off value levels, you see it. You see it as 1 and 2. So if you now on it, I mean, if you on it, you see the 1 and 2. If you off it, you see the normal male and females. Right? So it's now on. So you can easily see our values that we set. Well, let's just keep it up. There's no big deal about it. Okay. So descriptive frequency. I don't think we'll need student ID. We will just go with the age. Once you select the age, you push it to the variable box, and then hemoglobin level, push it to the variable box. Gender, push it to the variable box. Right. So tell it we need display frequency table. We should just create a frequency table for us, and then under statistics, we can just activate. Remember when we did all this data analysis table in Excel? Data analysis table in Excel, this is just a simple, is similar to what we did then. So we now have what we really want: central of tendency. We want the mean, We can still look at the median, the mode. I don't need the sum for now. So it should give us some quartiles, percentile if required. But this is standard deviation is needed, variance is needed, range, even square root mean, and then maximum and minimum is required. And then tell it to give us skewness. Let's know whether the data set are skewed to the left or to the right, right? And all right, so you now click on continue. All right, come to chat. I may need histogram. She'll tell you to give you some curves. Show normal curve on the histogram, and then continue. And I hope everything is okay. Format, I don't think everything is okay on format. And then style, I don't think I have any challenge with that. So everything is okay by me. So once you have set that up, just click on OK. You know, allow you to do the analysis. Okay, as you can see, this is an output window. All the analysis that will be done will be sent straight into this output window. All right, because unlike Excel, that everything will appear on the sheet, this one has an output window, and this is the output window. All your analysis from beginning to the end, all of them will be taking their space. As you scroll down, you will be seeing them. All right, so this is an output window, and everything we tick down there will appear here. So these are the statistics we have. The total number of students is 20. None is missing. Hemoglobin level. Okay, these are valid numbers. Gender. Sorry. This is the total number of students with 20. So the total number of hemoglobin that we have is still 20. The gender we have is 20. Missing values, none of them is missing. Now, under that, the age. Under age, we have the mean to be 11.9. So the average person there, average age is 11.9. And the standard error of mean is 0.32. And then the average level, imagine the mean for hemoglobin is 11. And then the mean gender is 1 and 2. So this is just normal calculation. It should be just 1.5 as the case may be. So the median is 12. The most occurring number, which is mode, is 10. And this is 2, as you could see. Standard deviation, variance for each of these information are being displayed here. The skewness is minus 0.39. And then standard error in skewness is 0.512. All right, so we'll have the range, we'll have the minimum, the maximum, and then the percentiles are being displayed here. So these are just the frequencies that can be seen at a glance. And then they now needed to bring, you remember that I told you to create a frequency table for each of them. So you now create all these frequencies for me. So telling me that 5% have age 10. So we have 10 people that are 5 persons that are 10 years old, 3 persons are 11 years old, and so on and so forth. So the information here are being displayed accordingly. Hemoglobin level are here, as you can see. Then the gender, you still print them out here. We have 9 male and 11 females, right? And then you now do this histogram for me and show the curve of how the information did flow in a linear curve. This is the frequency by age, right? And then hemoglobin level is the same by frequency, and then the gender and these curves. Okay, so this is just the very first information we could derive from this preliminary analysis, as you can see. Okay, let's go into that again. Let's look at descriptive. We checked frequencies before. Let's go to descriptive statistics and let's pick up descriptive. Okay, descriptive, let's pick the age, the gender, and still the hemoglobin. All right, these are the three information that we could work with. And then it's almost the same thing as the case me, as you can see. It's almost the same. But let's still continue with this. Let's say, okay, beautiful. So now the descriptive table has appeared for us. And then it has told us the maximum statistics here, the mean statistics, deviation, the skewness, and this is how he represents his own table, right? So with this now, we can also go straight into graph and now say, let's build one of the graph here. Let's choose which graph should we choose? Line. Let's start with bar first. Now, okay, so you can pick any of the charts here and drop it on the chat box here, and then you can easily pick what you want to rate age by hemoglobin level. Escape variable cannot be placed on an axis. I want to filter this if I can. If I can filter. It's not filtering. Okay, so we can easily create a chart here by choosing any chart, and then you drop it on this chart box, and then you now pick the variables here and place them on the X or the Y, and then the chart will just pop up. As you can see, the chart will pop up, and then at this point, once everything is okay by you, you just activate it and it will enter into the chart, the output information here. Apart from here, there's another way of clicking the same graph still under your data view. It's the same thing. We have chart builder here, and the same thing will happen. Just pick any of your charts you want. Let's pick a box plot. A simple box plot. And then let's say hemoglobin level. And then let's bring in gender. Then we click on OK. All right, so the box plot is created. Now, box plot has an upper range, an outlier, and then the median and the lower range and outlier. Now, if you look at this dot here that carries 13, this is an outlier. Outlier means a variable that is not in the boundary of other variables, that is above other variables, right? The variable that is like is not in the range of other variables is higher than the normal average. In fact, higher than the standard deviation of all the variables that are there. All right. So this thick line is the median, and then this upper line is the upper variable, like the apex of the deviation that is being felt from the mean, as the case may be. Now, this is the lowest, is an outlier. All right, 18 here is also an outlier. So for female, so 13 is the outlier for male, as well as 6. So box plot will help you to show the three information here, which we have here as the median, the upper range, the lower range, and the outliers. Right? Please, can you hear me, please?
Yes. Yes.
All right. So that is how to create a box plot. And then let us see a bar chart. Okay, we've created bar already. Let's do just one plot with our data set. And then we'll import a full data set so that we will explore some of the information that is required here. It's just a simple data set for field analysis. Now let's look at t-tests comparing means. Let's look at one of this information here. Under descript, analyze, get to analyze, and the next one you go straight to compare means, and then you choose independent sample t-test. All right, so very simple here. Let's pick age. No, let's remove age here. Let's pick hemoglobin level as our test value, and then let's pick age to be the grouping value. No, gender, sorry. All right. So this is the end result for the independent sample test that compares the means between the male and the female as regarding the hemoglobin level. So with this, we have the significant figure of 0.932, which is very high. And then we have the D of F and we have the two-tailed significant figure of 0.59, and then we have the mean difference. The standard error difference is also here, and then the 95% confidence interval is also here, the upper and the lower. So these are the means. Now the denominator used in estimating the effect sizes uses the pool standard deviation, as you can see. With this denominator, you can now know that hello, can you hear me, please?
Yes.
Okay. So these are the few display we could have for now, apart from creating a graph and all that. But since the data set is not really cognitive enough for us to do a lot of information, I will just import a data set now, and then we'll just run few of the analysis so that we could now understand the power of SPSS, why it's still functioning up to today. But after this now, once you have gotten this information here, the next thing for you to do is just to save, right? File, and then you click, since it's the first time, it will pop up save as dialog box. So you can now save to whatsoever you want to save. You just give it a name, then I'll say, maybe just call it hemoglobin analysis, hemoglobin, student hemoglobin analysis. Okay, so you just click on save, and then that is saved. All right, so since I'm done with that, let's just import one of our data sets. File, open, then you come to data. We have a medical data set that will be used for your tests, or perhaps we'll first use it for our class assignment, and then we'll now come back to make use of it as normal training by tomorrow. Well, let me send this data set we'll be using tonight is for finance, because a lot of things are happening under the finance world, especially the micro credit world. You may be required to be given a data set, and then you just go there and do the cleanup for them, and that will work immediately. Let me send the data set so that we could use that to do a preliminary cleanup as well as analysis as regards. But however, at this point, I don't know if you have any question to ask, so that we will drive from here down.
We can carry on with the next data set. Perhaps it could help drive down our understanding.
Okay. Joseph, are you here?
Yeah, sure, sir. I'm here.
Is Mr. Shola with us, please?
No.
Okay. Now, you saw how this came up. Let's say new first so that you understand. New data. All right, so we've opened a new one. So I want to import a data. So very easy. Open and then you click on data, and then you locate where your data is your data extension, a data file extension. The data we are using is an Excel file. So we just click on Excel and then we just pick this up. Pick it up and click on open. Okay, so immediately the data set has been previewed by SPSS. Data set has been produced. And then we have the ID, the age, the gender, the education, employment. As you can see, all the data set is okay by us. And then you just click on OK. Now, let me on the values. Okay. What is set values? Oh, the values were not set. Let's set up the values. Now let's set gender to be male and female. Now, first let me show you before you set up a value. If you look at gender here, found that we have 1 and 2, 1 and 2, 1 and 2. So the one there represents the male, and then the 2 represent female, right? Okay, so let's just go back to set up the values then. So just come back to your variable, and then under gender, click on set value 1. The level should be male, you add, then 2 female, then you add, you click on OK. So that has been set. The next one here is education. We have 5 of them. Just come up, set value. 1 is secondary school degree. 1 is secondary school degree. 2 is diploma. 2 is diploma. Then 3 is bachelor degree. 4 is masters. And then 5 is PhD. Okay. So once you're done, just click on OK. Employment. Let's set up the values for employment. Number 1 is employed. And this person is employed. Then number 2 is that the person is self-employed. And then number 3, the person is unemployed. 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 All right, so and the next one we're looking at to give values is repayment status. Repayment status. However, the repaid here should have carried the full. Let me just get this done. ID. Here is age. That is why it's good to put gender. It's good to put your level so that you know what stands for what. Educational level or qualification. Employment status. Then this is income. What is monthly income? Then monthly expenses. All these are monthly expenses. Savings. This still monthly. Debt. Then credit score. We have loan amount. And we have rate, interest rate. We have loan term. Our previous default. All these I'll explain it to you. We have debt income ratio. Debt to income ratio. And then we have repayment status. And then we have the default rates. Okay. So we're now looking at repayment status. Repayment status, we have, no, not missing. On the measure, main values first, sorry. Repayment, defaulted, and repair. So defaulted would be 0, 0, and then we'll put the defaulted. And then Y1 means the person pay back his loan. Right. And then the risks involved, we have 3 of them. 1 is low. 1 is low. 2 is medium. And then 3 is high. Okay. Now let's just go a little, let's preview this data. Let's see what and what it entails. All right, so normally the ID, we know about ID. ID just the customer ID that is being given. It's always unique. All right, so it has a width of 5, so the ID is up to 5 digits. So we now have age, it's numeric. Gender is also numeric, but the values has been changed as we understood now. Education is also numeric, but the values have been changed. Employment, the same thing, the values has been changed. Income normally is numeric. Then I told you about nominal and ordinal, right? So anything that is in between uh, text and numbers, we just keep it at nominal, especially gender. So income, expenses are all numeric. So that's why you now have scale here of all of them. Savings is a numeric value. Debt, credit is numeric loan. And then rate, interest rate is still numeric. In a term, by month, how long is still numeric. So preview default is numeric. Let me see what that means. Okay. So it's also scale, not even nominal. Well, all the same, it will still be under the numbers and values that it's being changed. All right, so debt to income ratio, DTI. So you can see debt to income. Let me put the two so you can see where the T came up from. Debt to income ratio. So this is also numbers. Repayment, we have the normal value that is being changed. We keep it at numeric. And then rakes, we have a value changed still under nominal. All right. So with this, the data set has been prepared, and then we can now come to the data view table to preview our data set. However, this doesn't carry names of people and all that. But if we want to put names, we can still put names, as the case may be. I don't know if you want us to put names. Do you want us to put names? We have 20 names here that is required. But nevertheless, names are not really the important thing for now because we'll not be using it. Well, we might be using it to preview, to filter out what is the name of the person carrying this ID. Okay. So at this point first, we needed to start with our normal analysis, but we are looking at frequencies for now. A frequency, under frequency, we'll just go straight into moving gender, education level, right? So gender, we'll just move it there, education level, employment to join, and then repayment status will join the repayment status will join, and then the default rates will be part of them. All right, so with all this, you can preview your chart here normally. But I don't want us to click on statistics because we'll need the statistics when we get into descriptive, right? So we'll just leave this one here now. Well, let's see one of the two charts we may just go with. Let's pick up histogram and let's leave it there. Show normal curve. Let's leave the curve for now. Now we'll just say, okay, now this will take up few of the information and spread them out for us in their different tables, right? As you can see, the total number of persons or the data set we have here is 20, right? And then we're previewing them through the light of gender, education level, employment status, repayment status, and default rates. Now, I needed to explain, let me just explain this data head to you so that you could be on the same page. Age is the normal age, we all know. Gender is normal gender, we all know. Education, we now know that this person is a bachelor degree holder and all that. Employment is something we understand that someone is employed. This one is self-employed. That means employed is working for somebody, while self-employed might be his own personal business. And then unemployed is our normal unemployed person that doesn't have what to do. Normal income of these persons are here. Expenses of these persons per month are these. The savings are these. The debt that is incurred are these. And then the credit score. You know, if you borrow money, they will see how you pay back the money, and with that they'll give you some score, credit score, right? So the more you borrow and pay back, the more you have more credit score to ask for more money, right? And then the loan as follows. As you can see, the loan amount, the loan that was collected, then the interest rate per this loan are like displayed here. Then the term is how long is required for them to pay back this loan. So this is 36 months, 48 months, 60 months, etc. Now on the previous preview default here should be previous default, not preview default. Previous default means that let's talk about this default first. Default means somebody that has not paid back the money. So he defaulted in paying back the money. So is there any previous default on that person? So 0 is no. The person paid twice, 3, and so on. 1, did he pay back on the due date? Yes is 0. But if he didn't pay back or he took 1 month extra to pay, so don't put 1, 2, 3, 4, etc. So debt to interest ratio are as follows, as you can see. So all this information we're just giving for our use, and then repay status. Repay status. Okay, this person repaid, this one has repaid, this one has defaulted, and then we have number 4 has repaid, as the case may be. We have some few that repaid their loan, and then we have few that have defaulted. In fact, you can also see that the risks do follow themselves, as you can see. Now, repay is low risk, defaulted is high, repay here is low, defaulted is high. We also have defaulted that is medium, meaning that they might have used previous default to determine this medium value, the same as this, right? So this is the actual sense of your data, so that as we are previewing the insight, we'll know what we're actually previewing, right? So this is the output of our data: the gender, the educational level, and then the employment status, right? The repayment status, default, as the case may be. So the gender are this, and then we choose the histogram. So that's how we're having this. It seems both male and female are of the same number. Okay, they are 10, 10. Okay, so we have 10 male as well as 10 female, right? All right, so we have the educational has been broken down. A lot of persons, or we have like 9. We have 9 persons having bachelor, right? Okay. All right, so employment status, as you can see, so 9 persons are having bachelor degree, 4 had diploma, and then 5 had masters and 2 PhD, right? So that's what we could see 9 here, then 4 here, and then we have 2 PhD. Okay. Employment status, we only have the 2 of them, which is the employed and the self-employed. We don't have anybody that is unemployed. Repayment status the same, and then the default rates is then breaking down into the 3 of them, which is the repay, the low, medium, and high. Okay. Are you with me? Do you understand to that point, Fatima?
Yes, I'm following.
Okay. Joseph, you're also following, right?
Yes, sir. Yes, sir.
Okay, so let's look at the second point here. We'll come to analyze descriptive statistics, and then we'll click on descriptive. Now, descriptive here, we just need to we'll pick age, income, expenses, debt, age, and then we'll pick monthly income. We'll pick expenses. How does he spend his money? We pick savings, and then we'll pick debt that is incurred already. Right, so we'll pick score, credit score. We pick credit score, so we could figure out what is there. We pick loan amount as well, since it's also. However, descriptive here only works with numeric values. Have in mind some of these are also numeric, so you can still pick them for analysis as well. Okay, so we'll pick interest rate. Now pick debt to income, and I feel like putting educational level, right? And maybe gender should also join. Right, if you click on these options, you can now activate your mean, standard deviation, minimum, maximum, variance, and then perhaps you could keep your skew on. Then click on continue. Okay, so with that, you can come here after everything is done. You click on OK. Now, on this output table, it has told us what we choose. So see, we have descriptive variable that was chosen include age, income, expenses, saving, debt, credit, loan, etc. So we needed to tell us all the things we chose and then gives us a descriptive table on that information that we have chosen. So as you can see, the age, the total number is 20, and then the minimum person there is 25. The maximum, the eldest person is 55. And then the mean, the average is 38. The deviation is there and all that. Okay, so we have the income as well. We have savings, we have debt. So these are kind of a breakdown for your preview. Like you can come and say, oh, what is the mean savings? What is the minimum loan amount? The minimum loan amount is 700,000. Have you seen this? Minimum loan amount is 700,000. All right, and then the maximum is, this should be 2 million. All right, so these are information that you need to have at your preliminaries to use this to make your information. Got it? All right. Okay, let's proceed. Let's create a chart regarding to this. Let's say chart builder or graph, chart builder. Let's pick histogram. And then we can preview this based on the educational level. And then let's look at monthly income. Then we filter by gender. Sort is okay by me. Sort is okay by me. It's male and female. We'll just click on OK. All right. So you now find out that the monthly income of a diploma is almost 400,000. The bachelor is like below. This is male and female. So that means the diploma holder had more money than the bachelor holder. All right. So these are the preview we need to see on our data set. So on the bachelor, this is like 380,000 for bachelor. The masters, the male earn more than the female. Then even PhD, the male earn more than 700,000 than the female that earns 650 or thereabout. All right. Now let's look at something else. Let's go deeper into this data set. Let's go to analyze again, and we are going straight into descriptive. And let's pick explore. Let's explore this data. Descriptive and then explore. And then under explore, we considering income as the dependent value, monthly income. as a dependent value. And then we'll put employment factor, employment into the factor list, employment status into the factor. Or perhaps you could label the cases by a gender, but I'll just keep it that way for now. Let's look at the plot. On that plot, let's pick histogram. You can, as you can see, you can pick these two, but let's see how that looks like. And then we'll keep the normality box. The normality plot we test should be activated. And then, very simple, click on continue. And then you click on, I have in mind, the display have both the statistics and the plotting. So let's see the two together. Here is activated by both. Then click on OK. Now, this is the statistics now, right? Now, it describes even the 95% interval on both the monthly income, right? The upper bound, the lower bound is describing that for us. And then you now pick both the employed and the unemployed. Now, it now says that the upper bound of, in fact, the average of the employed is 438, right? So that means the person should have enough money to pay as when due, of which the fraction can be determined for how much you can be paying per month to even cover up it, to cover up for his debt, as the case may be. So we have the self-employed comparing their mean income, and then the 90% confidence interval is 200,000. Their mean is 300,000, 333. So it could be very comfortable at the 95%, which is 200,000, 312, right? So if 5% is trimmed, of which you could see, now the median will be 285. And these are the information that are there. So, and he needed to create out the histogram for both the monthly income and then that of employment, self-employed, histogram for employment and histogram for monthly income. So you can see now. So we have this plot, stem and leaf plot, and then the normal QQ plot for monthly income for based on the expected and the observed. So he even gave us a straight linear graph that is even very good for them to pay up for their analysis for their debt, as the case may be. So these are the QQ plot, and then he also gave us the box plot. I showed you something concerning the upper bound and the lower bound and the median. Oh, this is the median and this is the mean, right? The thick line is the mean. The blue line, the blue box is the median. So this 17 here is an outlier. This thick line is the mean. And then this 17 is an outlier. This blue box is the median. That is where the median falls, right? Okay. So these are few analysis for the preliminary information gotten. Now, if you look at nominal test, especially when we're looking at Shapiro-Wills test, to give us more information concerning this data set, very simple. Analyze, descriptive, explore. Okay, we have done that. but we did not put dependent together. Let's try this dependent together. Let me remove this. But it may duplicate the information, but there's no challenge with that. Let's say plot alone. Okay. So plot alone. Let's click on OK. All right. So these are the plots, as you can see, and it is just almost the same thing we have. Now, the probability. Let me bring you back here. Now, this is Shapiro-Wilk, right? Shapiro-Wilk is one of those analyses that normalize what we were trying to see, the correlation between the income and the income of each of these persons in relation to the employment status, right? The monthly income in relation to employment status. Now, Shapiro now will help us to get, let me bring you to the table, the probability of 0.05 have, when once it's greater than 0.05, then there is no significant evidence of normality. Once it's greater than 0.05, then there is no significant, meaning that there is no relationship between your employment and your monthly income, right? But if it is less than 0.05, then two of them actually depend on each other, right? If it is less than 0.05, two of them, which is monthly income and employment status, actually depend on each other. So they said this is a lower bound of the true significance. Now we have Shapiro significance here is 0.23. 0.23. And now I gave you the boundary that if it is greater than 0.05, then there is no significant evidence against the normality. There's no significant evidence against the normality. But if it is less than that, then there's a significant difference from the normality level. As we are testing the test of normality, right? I know Fatima has a question. Well, just type the question for me on the chat box. Fatima, are you there?
Yes, I'm here.
Please type that question for me on the chat box. Now let's look at crosstab analysis. Crosstab is to preview if the repayment status is associated with the gender, right? We want to check if men always pay back their money or whether female do pay back their money as at when due. So very simple. You click on analyze, descriptive statistics, and then you click on the cross tab, and then you bring in gender into the role, and then you bring in repayment status to the column. Repayment status to column. So when that is done, click on statistics. Let's see one or two information that could be gotten from there, and then activate chi-square. Let chi-square be on. Then you should activate one or two things here. Let's even activate correlation. Let's see how that will go. Now you can activate any of this so that it will give you more information as required, right? Cells, let's keep cells on row, and then we'll continue and click on OK. Cross tab, picking those two, we have 20 input here, and then we're looking at male and female, few information about them, which is 50-50%. Yes, they are 10/10. And then we're looking at chi-square here, right? And then if the probability is less than 0.05, then gender affects repayment. If the probability is less than 0.05, then gender affects repayment. But if not, if the probability is less than, so if the probability is greater than 0.05, then gender does not affect repayment, right? Gender does not affect repayment. So you can see now. So these are chi-square tests showing you the exact significance figure for one-sided and as two-sided. So we have one-sided 0.175, then the two-sided is 0.35. Now the probability here, the minimum expected count is 3.50, so the probability is far more bigger than 0.05. So does also mean it means that gender does not affect payment of debt, right? So these are few analysis that could be gotten as the case may be. So we have chi-square test using hypothesis, right? We have null hypothesis and we have the alternate hypothesis. So very simple. You can set up your hypothesis that gender and repayment status are independent for your H naught, and then your H1, you can say that gender and repayment status are dependent, right? And then you now set up your decision rule that you should reject H0 if the probability is less than 0.05, right? So this is chi-square test, chi-square test, right? Now, I just want us to go straight into independent samples t-test. Now, here is like, it's like to ask a question: does average income, differ between customers who repays their loans and those who default? Does average income of every customer, does it affect those who pay their loans and those who doesn't pay? So these are few t-test samples that we can compare. Very simple. Just come here, analyze, and then come to straight to compare means, and then we choose independent sampling. Independent sampling. Then with this now, just put the income. Put income in test, which is monthly income. Put money income in test, and then repayment status, put it under grouping variable. Right. Repayment, put it under grouping. Now let's click define group. Okay. There's the two groups, the default group and the repaid group, right? All right, so with this now, you just click on OK. Is that one of the group is empty? All right, let me check it again. Analysis. Compare means independent sample. Okay, it's actually 0 and 1. So group 1 is 0, group 2 is 1. All right, so the two of them are the same. Okay, so we were asking that if we're asking the question that does average income, the customers that have a good average income, does that income allow them to pay back their loan, right? Does average income differs between customers who repay loans and those that don't repay their loans? So now, looking at the independent sizes here, we could see that the denominator used an estimator estimating the size, the effect size. Now, the H correction uses the pool standard deviation plus the correction factor, while glass delta uses the sample standard deviation of the control group. But the actual understanding here is that if the probability is less than 0.05, then the income differences between the two groups is possible. There's a possibility of such happening. Now let's see, let's just project this in a graph. Let's pick box plot. Box plot, we'll pick the income, monthly income, and then we'll pick repayment status. and then we'll click on OK. As you can see, we have the repayment group, right? The repayment box is giving us a very high information as regards the monthly income. So that means those that have high monthly salary actually pay up their debt compared to those that default. So that we can now say that high income somehow help in paying back the loan that was collected by a customer, right? So we now have ANOVA 1. If you can remember, ANOVA 1 that was done when you were in school, ANOVA 1, ANOVA 2, ANOVA 3. So one of these ANOVAs may likely to ask the question, does monthly income affect educational level? Does monthly income affect educational level? So very simple, still on our analysis, then we just come straight to compare means. Then we choose our ANOVA one way ANOVA, right? So on this one way ANOVA, we want to compare whether monthly income differs from educational level. So we will pick income into dependent, monthly income into dependent. Then we'll now pick our education of into factor. All right. Post hoc, get Turkey. Is it Turkey? Sorry, like saying Turkey. Turkey, and then the options descriptive. Keep descriptive under options. Open a descriptive, let it be ticked. Trying to give us more understanding as regards that. And then homogeneous should also be ticked, or variant. Homogeneous should be ticked. Perhaps you can plot up the means. And then you keep this as a 0.95 confidence interval level. All right, so with all this information done, just click on OK. Now the analysis will come down to what we can find here, right? Remember, we are asking, does monthly income differ in educational level? If we have 0.05 less than in probability, then at least one group shows a different. If we have such, as you can see, we have a significant of 0.01. So that means there is somebody that the group actually affect educational level. The significance here is 0.01. So we're saying if it is less than 0.05, then there is a difference. So it is already 0.01. There is actually a difference. So we now have the plotting. As you can see. Let's look at correlation. We'll just do few and then we'll call it a night for today. Correlation. This is to view credit score with others. Analysis. Come down to correlation. Correlate. And then you choose your bivariate. Then let's look at credit score. Credit score. Move credit score. Then you move income. You can pick and drop. So I'm just done now. So move income and then move savings and debt. Let's see the correlation between all this. You check the loan as well, the loan amount, and then DTI. Let's check that too. And then keep this at Pearson. Normally, this is the one we have. We'll keep it at 210, as you can see. And let's see if we could activate one of those things here. A means and standard deviation. Let's keep it at that. And then we'll keep on. We can continue on that. They say, okay. All right. So our correlations is actually beautiful when it comes to Python. That is Jupyter Notebook. You really appreciate correlation there because they'll use colors to beautify this. Then you can easily see how things are being correlated accordingly. Right? So correlation means, is there any relationship? Could there be any relationship between these variables? Would there be any relationship between these variables? Now, credit score and monthly income, are they related? Is there any close relationship between them? So it will just come up, as you can see. So we have the 0.05 level for the star one, and then we have the 0.01 for the star two, as we stated here. So now the mean in regards to all these variables are what we could find here, 677 for credit score, and then the standard deviation, as well as the total number of information gotten. All right. We'll just do just one, and then we'll call it a night from now. And then we could come back tomorrow, and then we go back on this once again. We check some of the meaning of these mathematical terms so that we really understand what and what these calculations means, right? And why are they being used as they are being used? Fatima, can you hear me?
Yes, very well.
Okay. Let's look at multiple linear regression. Now, multiple linear regression is regarded as what factor predict loan amount? What factor do you use to predict the loan amount? What factor do you use to predict the loan amount? Very simple. Analysis or analyze, straight to regression, and then come down to linear regression. Now, what factor will you use to predict the loan amount? So just push loan amount into the dependent, since it's the factor we're looking for. Then bring in the income, savings, and score into the independent, right? So income will come here, monthly income of the person. I don't think we need expenses. We don't need the expenses of the person. Monthly savings of this person, and then monthly score, credit score of the person. These are the things that will bring in the information that is required. Then interest rate of that the person might need to be given. Then the time, then the last one is debt to ratio. All right. So with this now, these are the factors that we use to determine the loan amount per customer. Right. So let's look at under statistics. Just keep it at estimate. Okay, it's already at estimate. Then model fit is also checked. Just keep those two. Then confidence intervals should be our normal 95. Right. So connectivity diagnostics should just be checked. Convergence matrix can also be kept checked. Now, most times people do go with descriptives, but we've been doing descriptives all along, so we really don't need that for now. All right. So on that plot, let's take zipred into X, and then Z reside into Y. Sometimes people want to keep this on normal plot and histogram, or even as previewing these two. All right. So with all this, and you are good to go by clicking on OK.
Mhm.
So we have our granularity diagnostics, right? Using our loan amount as a dependent variable. Now, if R2 is 0.72%, that is the predicted value, the minimum predicted value, or if you have the probability of 0.05, that is less than 0.05, then there is a collective explanation as regards those variables contributing to a loan amount that's been given out. Now, as you can see, even the regression standardized plot is having a very smooth slope. And then our scatter plot as well, as you can see, for each partial regression dependent value based on loan amount. So they are giving a positive information as regards the credit score here, the interest rate. But this is a scatter plot. Okay. So Fatima, at
Yeah.
this point, we'll just pause for now, and then we'll
Okay.
continue tomorrow. Right.
Okay. Thank you so much.
After you're done like this, you will just click on your save so you can continue.
Okay.
This is financial finance app. Then you just click on save. So you can continue from here tomorrow. Thank you for your time. We'll continue on this data set. Go from afresh. We'll start again tomorrow.
Okay.
So that there are some questions. I don't know whether you type in a question for me. All
No, I
right. So,
didn't type it in, but
so yeah,
I'm looking at maybe tomorrow.
yeah.
Start all over again, but this time around, um, I'll have the data set. Then I don't know, with you taking the lead,
Okay.
then see how far I can understand it.
Okay.
Yeah.
All right then.
Thank you
Thank
so
you.
much.
See you tomorrow. Have a nice
Yeah.